Okay, good afternoon, everyone. So welcome back to the next week, the second week of the course Introduction to Computer Science. Alright, before we continue to our first chapters, I would like to remind you for the grading policy. In case you forget about the requirements of this course, okay, here I am to remind you again. Okay, since this is a distance learning course, so starting from next week, you don't need to come to class. You only need to study from the iLearning system. Okay, it's the same with artificial intelligence and basic Python. You don't need to come to class to study. Just access your iLearning system, watch the video teaching, and then fulfill the requirements. And then you can pass the course. Okay, it's easy. Okay, let's start from the beginning. The requirements of this course will be okay. The first requirements of the course is the assignments and the discussions. It's 20%. We have total of 5 assignments and 5 topics on discussion forum. So don't miss any of it. Next one, it's the midterm exam. It's the online test, and it contributes 30% for your final grade. Okay, it's 24 hours. I always remind my students to set reminders. Okay, since this is a distance learning course, a lot of students forget that they have the midterm exam they need to perform. And that is on April 14th, I guess. Okay, later I will tell you. Okay, and then the final project, it's a group final report. So later we will discuss. I will decide what is your time for you to do the report. And then a final exam, it's online test and it's only available for 24 hours. So for final exam, also you need to set a reminder on your phone. Have you set a reminder on your phone? Yes, already? For the midterm and final? Yes, okay, good. Okay. So in the future, I hope no one of you are asking me, is there any other chance to take the exam? Okay, I hope no. I hope no one of you. Because you already know my answers. Okay. For the online assignments and discussion, there will be a total of 5 assignments. The first 2 need to be completed before midterm week, and the other 3 need to be complete before the final week. Okay, you already know this, and I'll just remind you. And the other topics, the 5 topics on discussion forum, it's part of the assignments, 20%. So you need to also post on comments the reply to the topics that we are discussing on the iLearning system. And okay, so this is the online test for the Introduction of Computer Science. It's on 17th of April, okay? If you haven't set a reminder, you can set now. Otherwise, you will miss the test, okay? Because it's only 24 hours. So if you forget, then no, you're not dead. Okay? It's a multiple choice question, so it should be easy. For the final report, this is a group final report. So I believe that you are here. You already decide who is your teammates. Maybe also the date that you are going to present your report. Okay? You know that one group consists of 1 or 2 people. So 2 people is the maximum. Okay? Teacher, can I teammates with my 2 friends? So total of 1 group will be 3? No. No. 2 people maximum. Because based on my experience, if there are 3 students at 1 group, the other students will, she or he not working. Okay, so only 2. Yeah, you're smiling, so you know. Okay, and later on, I will put the paper in front of the desk, so you can choose what date you want to present your report. And on the presentation day, all group members should be at the class. Yeah, should be here to present. The absent member will not receive a grade. Please keep this in mind. And changing schedule is not allowed unless it's an emergency. Okay? And the other groups who are not reporting, if it's not your turn to report, then you can skip the class. Okay? So on the day of the presentation day, I expect the groups who are present to be on the class. Everyone, the members, yeah? And, okay, the PPT, please submit to email. Please send to my email. Okay, I haven't told this last week because one of your friends asking about the final report. Since you need to give examples of the topic, and I hope that the examples is difference between one group and another. So your friend asking me, how if we don't know if the examples is already used by another group? Okay, so to prevent this, you send to me first. Okay, send to me first. The groups who, okay, for example, there are 2 groups having the same study case. Okay, the first groups is deserved to have the case. The other groups need to change. Okay, got it? Understand? Okay, for example, there are 2 groups who is presenting today. Okay, 2 groups presenting today. They both have the same study case, have the same examples of the case. The first group who sent the PPT to me deserve to get the examples. They can go with the examples. But the later groups having the same examples, they need to change. Okay? So it's better for you to send the PPT to me as soon as possible to avoid the changes. Okay? Understand? Understand? This is very important. Okay? So the PPT, you can send to me like 1 week before or 2 weeks before, it's okay. But at least 1 day before, send to me. Okay, so I can check your examples. If it's same with the other person, you can still have time to change the examples. Okay, examples is the study case. Okay, I will re-explain to you again. All right. So this is the topic for the final report. Okay, this is the topic for the final report, 1 to 6. We can choose by using lottery, but I think it will take times. And let me check if I still. I still have the paper.
你们是两回，你们是一个人还是两个人？你说上一节课吗？是吧？一个人。我想这一节不要一个人，还是今天全体？全部是全体。那走路从另外一个地方，我光是身体就全部都是学的，走这个记录，走这个每个记录。
Okay, so I have 14 number here. It represents each week. So we have 14 groups for each week. Okay, so I hope after you write down your time to present, you write down your name and student ID. And then I will call per week to choose the topic. Okay. For example, week one, come forward. It's just one of you or one of you. No need both of you come. One of your group, one person of your group, choose one paper, and then after that write down on the left side of the table, okay? Write numbers, just numbers. Okay. Alright, so this is the topic that you need to choose for your final project. 1, 2, 3, 4, 5, 6. And then you need to give real life examples. You need to give real life examples of the topic to present. The example should be unique and differ from one group to another group. So I hope it's your real life case from your everyday life. Then you can use it as the examples of real life examples. So to prevent the same cases with your group, with the other group. Okay, your real life examples. Okay, any questions about the final project? No? Okay, quite easy and understand? Okay, before we decide to write the schedule, then I will continue to the last. It's the final term exam. It's also an online test and 24 hours. So you can start to set the reminders on your phone. Yeah. Yeah, on your phone. On your iPhone. Because if you fail to take the exam, I'm sorry, I cannot give you another chance. Okay. Oh. So we will start the final report on May 29, June 5, and June 12. Each week we'll have 14 groups. 14 groups. Okay? So let's say this is week 1, week 2, and week 3. And we are 2 hours, right? 2 hours. 2 hours. So each hours I will have 7 groups. Okay, let's start. Week 1. Week 2. Week 3. Lie. I love it. Oh, yeah.
这个好像没咋比。
Everyone is starting to choosing. Oh, 小心小心。Everyone is deciding to when is their final report will be.
Please ask them to come or ask you to write down the schedule. Okay? Okay, we have 13 groups for week 1. So for week 1, you can send your friend to come to choose the topic. Only one of you is okay. And then you can write down the number of topic on the left side of the group. For week one, okay? Week first of week. Week one. Week second and third later, okay? Week second and third later. Four. It's 4. Sorry, it's 4. Okay, just put the paper bag on the table. Put the paper bag on the table. It's for week first. Week 2 and week 3, please wait. Later. Week 2 and week 3, later. Week 2 and week 3 later. Next, week 2. Week 2, you can come. Week 2, you can come. And write down the topic numbers on the left side on the table. Week 2, week 2. Week 2.
我还帮你看。
你还要验票是不是？我不会黑箱。
他直接。
Week 2.
哦，他知道一个哦，知识的意思对吧？这种帆船可以去吧？
是，
哦，是
57，
是
57，对。
我是。
这个要放回去吗？ You want to see the topic?
This is the topic. So 没有7，没有7。对，1、2、3、4、5、6、7，没有7。1到6，没有7。Okay, week 2, okay? Week 2, okay? 2-9 and 2-8. 2-9 and 2-8. Can you help me? Tú chào ở Thái哪里？ What number topic are you? 2-8 and 2-9. 陈婉宇。Choose the topic. Group 2-8 is not here, then I will choose for you. 2-8 11244 170 11244 不在吗？不在吗？那谁的写？ Oh my God, so scary. Okay, next, week 3. Week 3. Week 3. San. 5 Oh, just put it there, it's okay. I will choose for group 2-8. Okay? 2-8, topic number 5. Okay. I hope you don't forget the schedule. Later I will scan this paper and upload it into iLearning system so you won't miss the presentation day. Okay, just in case you want to change. Okay. Any questions about the final report? Questions? No questions? Okay. One of your friends asking me, what is the chapters for midterm exam and what are the chapters for the final term exam? I will give the details on the announcement, so don't forget to check the announcement on the iLearning. Okay? Okay? If you don't have any questions, then I will move to chapter 1. Okay, we will continue our class. Our first chapter is introduction to computing. Introduction to computing. So in this chapter, I will talk about the role of algorithm, the history of computing, and overarching the terms of the computer science. Okay, the role of algorithm. If we're talking about algorithm, it's more like steps of how to do something. Okay. So informally, an algorithm is a set of steps that defines how a task is performed. For examples, there are algorithms for cooking called recipes, right? So for examples, I want to cook egg. Okay, the recipe. You buy the egg at the traditional market, and then you prepare like 2 eggs, cracked it on your bowl, then mixed it, put some salt and maybe soy sauce or any other powders like garlic powders if you like it, and after that heat your pan, put on some little oil, and then start to cook your egg. That's called recipe. It's not recipe. Recipes. No, it's not receipt. Receipts. How to pronounce it? Receipts. You know what I mean, right? It's not receipts, paper. No. It's the receipts how to cook something. Okay. And algorithm, it's for finding way through strange cities. Oh, it's break time, right? Okay, we have 10 minutes break. We'll continue after the 10 minutes break. Okay, let's continue so we can earlier if the chapter is finished. Okay, let's talk about the role of algorithm. So algorithm is a set of steps that defines how the task is performed. Okay, for example, there are algorithms for cooking called recipes. Maybe for finding your way to your location, we call it directions. For operating washing machine, which usually displayed on the book, manual book, and for playing music, yeah, for example. So the study of algorithm, it became as a subject in mathematics. Became as a subject in mathematics. And indeed, the search for algorithm was a significant activity of the mathematician long before the development of today's computers. So the goal was to find the single set of directions that describe how to simplify something. How do we choose which one directions we choose to simplify in doing something. So algorithm serve as the backbone of the machine learning. Machine intelligence and artificial intelligence are both the backbone of the machine intelligence. And it provides the framework through which machines can exhibit the intelligent behavior of the and carry out the useful tasks. So the intelligence demonstrated by the machine is the constraint by the intelligence conveyed to the algorithm. So if you want to do something, if you are familiar with programming language, the algorithm is how to perform, how to solve the problems. And programming language, it starts from a problem, right? And if there's a problem, then you need something to solve the problem. And we need algorithm in this case to set some steps to solve the problem. And program, like programming language, the software that you are using on your smartphone or your laptop, it's one of the things that represents of an algorithm. And then coding, the programming, it's also the process of developing a progress in coding in a machine compatible form and inserting it into a machine. How to code programming. Okay, it's to solve the problems. And then software, it's next level of the coding. After your coding is finished, and then it will become a software. So software in this case, it programs and the algorithm they represent. Now the history of computing. I know the material is quite boring, so yeah, you can sleep. Because it's telling you the history of computing. It's like telling you the story before your bedtime. Okay. All right. During the ancient time, we start from the ancient time, where the computers, it's not computers like nowadays. It's is like an abacus. So the abacus is like the picture on the right side. It's the abacus. So it's the early device of computer in ancient times. So the abacus likely originated in ancient China and was used in early Greek and Roman civilization. During my childhood, I used this a lot. Abacus. I use abacus a lot because calculator is not allowed to use by kids. So to calculate something, my parents buy me this, and there are a lot of like cram school, cram school to study how to use this kind of abacus. My time is not an ancient time. Not an ancient time. I'm not that old. But during my kids, I'm using this a lot. Is the abacus. And I'm not sure that kids nowadays are using abacus that much because technology are getting advanced. You can use your phone to calculate everything, right? Okay, so it's a simple device consisting of bits on rows within a rectangular frame. With the bits position represents a stored values. However, it requires a human operators to control the execution of the algorithm. The abacus needs us, the humans, to operate. Otherwise, it cannot. It's useless. Alone, the abacus is incomplete as a computational machine, so it needs a human interactions to perform the computations effectively. And we move forward to the Middle Age and before the modern era. So the computer machine, it's more advanced at this time, and that we have a lot of inventors at the time, such as Blaise Pascal, Gottfried Wilhelm Leibniz. Oh my God, this is very difficult name. And Charles Babbage. So they are the pioneers of representations of data through the geopositioning. So in the Middle Age, the data is already used a lot, but they still not using a computational program, something like that, like nowadays. They use tier position. To memorize the data. Tier position. And then Babbage, on the other hand, foresaw the needs for machines capable of directly printing the computation result to mitigate the transcriptions error. I should have pictures of that, but okay, let me find later. And these early innovators laid the groundwork for a significant progression in the algorithm flexibility. So Pascal's machine was limited to addition and with algorithm embedded within its structure, showcasing an early examples of algorithm execution within a computer device. And okay, still in the Middle Age and before the modern era. So Leibniz machine allowed the selections from various arithmetic operations. It's still embedding the algorithm within its architecture. And the Babbage difference engine It's capable of various calculation, and it's programmable, and it has an analytical engine designed to read the instructions from the paper. Okay, there are some more invention like Ada Lovelace. They demonstrate the programming concept for the Babbage's analytical engine. So the Ada Lovelace is recognized as the first programmer. And then, okay, the Babbage idea of communicating algorithm through the holes of paper was inspired by the Joseph Jacquard's waving loom. I think I have the video. Please wait. I think it's more interesting using a video rather than listening to me. Wait, I have a video of that. And I hope the audio in these computers works. Okay, please wait.
I want to learn English as a second language. Writing has always been something that I feel a little bit self-conscious of. That's why I've been using Grammarly.
The history of the computer dates.
Okay, let's watch this video about the history of the computers.
Back to the 1800s, when many scientists began to develop various computing machines. However, the modern computer was developed in 1930s, when Konrad Zuse created the first programmable computer, the Z1, which could do additions and subtractions very quickly. In 1941, he created the Z3, known as the world's oldest digital computer. Unfortunately, the computer was destroyed during World War II, but later in 1950, Konrad Zuse used the Z4, the world's first commercial digital computer. Another important moment in history and evolution of the computer was also in 1941, when J.V. Atanasov, a physics and math teacher, and his student Clifford Berry designed a computer that could solve 29 equations simultaneously. However, Atanasov-Berry computer was the first computer capable of storing data in its memory. In 1944, the Harvard Mark I Colossus was inaugurated. A huge computer that occupies an entire room. It was used during World War II to break the complex Lorenz ciphers used by the Nazis. Colossus offered immediate solutions, and it's believed that it significantly shortened the duration of the war. Another computer that stood out at the time was ENIAC, created by John Maxwell and Presper Eckert. The computer was created for ballistic analysis used by the military during World War II. ENIAC occupied a room of 1,500 square meters, weighing 30 tons, and had 6,000 switches and 18,000 vacuum tubes. A few years later, the two built UNIVAC, the first commercial computer for business and government applications. Another important step in the evolution of computers was the time when transistors replaced vacuum tubes. Thus, in 1953, the first prototype computer with transistors was created, Manchester TC. In 1953, Grace Hopper developed the first computer language called COBOL. At the same time, IBM created its first computer called IBM 701. In the early 1960s, IBM launched the 7000 series of mainframe computers that use transistors. The 7030 model also calls Stretch was part of this series, with 9 such computers being sold to scientific laboratories. The technologies used for this computer led to the development of the IBM 360, IBM's most successful series of computers. Slowly, the evolution of the computer was approaching what we know today to be. In 1965, Program 101 was the first desktop computer sold to general public. It cost $3,200, was the size of a typewriter, had 37 keys, and a built-in printer. At the same time, the world's first 16-bit commercial microcomputer, the DDP-116, was developed and sold for $28,500. The year 1970 is marked by Intel, which launches Intel 1103. The first dynamic access memory chip, DRAM. A year later, IBM invented the floppy disk, which allows data to be shared between computers. Now, who hasn't heard of Altair 8800? It was launched in 1975 and used the basic programming language developed by Bill Gates and Paul Allen. Altair 8800 was a very popular computer, being the model that invented the term personal computer. In 1976, Apple appeared on the computer market with the Apple I, the first computer with a single circuit board and ROM, to which you had to add a keyboard, a power supply, and a case. A year later, they launched Apple II, which was a great success. It was an 8-bit computer and came with a switching power supply, keyboard case, manual, game paddles, and a box containing the Breakout game. In 1981, IBM launched the first IBM PC, officially known as the IBM Model 5150. It was based on a 4.77 MHz Intel 8088 microprocessor and used a Microsoft MS-DOS operating system. This was the computer that revolutionized the development of computers, being cloned on a large scale and thus generating the creation of so many softwares and peripherals. Apple launched Apple Lisa in 1983, the first personal computer to have a graphical user interface. It had a drop-down menu and icons, a Motorola 68000 microprocessor, 1 MB of RAM, a 12-inch black and white monitor, dual floppy disk drives, and a 5 MB hard drive. A year later, Apple introduced the Macintosh, the first successful computer mouse with a graphical user interface and based on the Motorola 68000 microprocessor. In 1984, Michael Dell created PCs Limited, where he created the first self-designed computer called Turbo PC. In the early 1990s, Dell was one of the leading computer developers. In 1987, IBM released Personal System 2, the first IBM system with the Intel 80386 chip. The computer also came with a new operating system, OS/2, which for the first time allowed users of a mouse for IBM computers. The 1990s were marked by an innovation introduced by Apple, their new iMacs. The 1998 G3 came with clear, customizable case. It was sold for $1,300 and included a 4 GB hard drive, 32 MB RAM, a CD-ROM, and a 15-inch monitor. Apple also marks the 2000s. In 2003, it launched the Apple G5, the most powerful Macintosh to date. The computer had anodized aluminum case and was named the first true 64-bit personal computer. So, in the 1990s, with the advent of the internet, personal computers began to be widely used in all fields. Gradually, computers evolved drastically, both in terms of design and performance. Thus, the market for computer components began to grow more and more, with users being able to create their own PC system according to their own needs. Moreover, it is incredible how from computers that occupied an entire room and performed very simple actions, technology has come to offer us today very small PCs such as the Apple Mac Mini desktop PC system, which offers very high performance when working or doing a gaming session. So we have all the evidence that technology is not standing still, but constantly evolving from day to day. What do you think computers will look like in the coming years?
Okay, I think it's very interesting. If we watch a video, it's more make us understand how the history computers from time to time. May I know what year you were born? What year? 2000? 2000? 2003? 2005? 2007? No, okay, so maybe 2005. I was born in 1990, so I experienced a lot of computers changes in my life. I want to show you something. Floppy disk. Wait. It was. I think it's it. Have you ever used this kind of disk in your life? Have you? I believe no. Since you were born in 2003, 2004, 5, I believe that you were not using this kind of technology. It's me using this kind of technology in 2003. So it's the time when you were born. I'm still using this kind of technology to keep files. So my teachers back in the senior high school, back in the junior high school, when I want to submit a paper, no, it's not paper, Word files, I need to put it in this floppy disk and then put my names on it, I write my names on it and then give it to my teachers. Everyone's in my classmates, they do like this. Okay, when they want to submit a Word file or PPT file, we use this technology. So it was there was no cloud computing and email. I think it's already there, but we are not familiar with it. Yeah. There is an internet, but it was still something. How to say? It's expensive. Yeah, internet at my time is very expensive. It's not like today's era where everyone have an internet available everywhere. Yeah. That time, internet is very expensive. You have to pay a certain amount. It's not cheap. Okay. Okay, that was the history of computing, so I don't need to explain to you how the computing is developed from time to time, from ancient time when it started from the abacus, and then moving to the next years when the inventors using the transistors and the microprocessors and became nowadays personal computers. And at the ancient time, the computers is as big as this room, and it's very hot. You know, the machine is very hot at this time. Okay, let's continue. Okay. Okay, now we'll talk about the algorithm in the early time computer. So limited data storage capabilities and intricate, time-consuming the programming procedures. It restricted the complexity of the algorithm used in the earliest computing machine. So, however, as these limitations began to disappear, the machines were applied to increasingly larger and more complex tasks. So, as the consequences, an inventor called Gödel's incompleteness theorem, mathematicians had already been investigating those questions regarding the algorithm process that advancing technology was now raising, which now the discipline known as the computer science. So for today, computer science has established itself as the science of algorithm. And all of these researchers are involved in aspect of the science of algorithm, given the central role that algorithm play in the computer science. And we need to study more about what is actually a computer science, what the field covers in this computer science, because it's a big study field. Okay, and abstraction. So abstraction is the fundamental concept that transcends the disciplines. It facilitates the creation and the understanding of the complex system, such as computers, automobiles, and microwave ovens. By concentrating on the external properties rather than internal intricacies, the abstraction enables the constructions, the analysis, and the management of the large computer system. So the abstraction is not limited to science and technology. It's crucial simplification technique that permits the society, allowing people to utilize various convenience without the understanding their underlying the implementation. Okay, so it's still about the abstraction. So abstractions serve as the cornerstones for social progress. It's enabling the specialization across the various domains and empowering individuals to leverage the abstract tools to derive from the collective knowledge. And then data. In the modern landscape of discovery, the algorithms serve as a vital role, not only for transferring digital data within the computers, but also for empowering the preventing risk tests, such as pattern recognitions and then simulations, creation, and correlation analysis. And then programming. So programming, the process of translating the human language into the machine language. It's known as the programming, it's coding, something like that. So while computer science talking more about just then programming, the ability to execute the algorithm remains a fundamental skill for all the computer scientists. Okay, and then internet, you know internet already, yeah? The internet stands as the transformative force, reshaping how we store, how we access, how we retrieve data, information on the global scale, profoundly impacting domains like commerce, yeah, how we buy items. It's not like the old days where we go to the physical store to shop something. We're now more, we have two options. You can do online to buy your items you want, or you can buy on the physical store. So we have two options. And the two options can be done based on your preference, like what items you would like to buy and what the price. Yeah, you prefer the cheaper price, but you don't know the items just yet, or you pay more money at the physical stores, but you can choose whether to decide to buy or not. Okay, so it's also impacting in commerce, how we buy something. And then news dissemination. In the old days, we watch news on TV. We know what is updates on reading the newspapers. But now you can access to the latest information just from your phone. And then entertainment. Okay. We are talking about, one example is like Netflix. This is how the revolutions of the TV nowadays. In the old days, we need to watch TV to watch the entertainment. Or you go to the cinema to watch movies. But nowadays, if you register as the members of Netflix, then you can watch movies like anytime, anywhere, as your as you like. And then the social impact. Okay. So the computer science stands as a powerful force shaping the landscape of communication, work dynamics, and social interaction, including how you interact with your friend. It's not you are meeting in person with your friends. You can meet your friend by using social media or video call. Yeah, a lot of changes. Yeah, based on the technology nowadays. All right, do you have any questions about the chapters we have learned today? It's completely a basic idea of algorithm and how it relates to the computing science. Okay, if you don't have any questions, then we can finish the class here. Don't forget that we start the distance learning next week, and I will see you again on the final report day. Okay, don't forget, and I will post it on the iLearning just in case you forgot when to do the presentation. Okay, see you. Bye bye.